Hello friends, welcome you all. So in this video, we will discuss another kind of Turing machine, which is known as transducers. So Turing machine, when working as transducer, so it generates some output based on input. So it can generate any kind of output based on what input you have given to it. In previous lectures, we have discussed Turing machines that we are working as acceptor or recognizer. So how these Turing machine will generate output, that we will discuss. And as you can see here, I have taken two example of Turing machine here, that is working as transducer. So Turing machine for one's complement, Turing machine for two's complement of given binary number. And as you know, friends, you have in, input tape on in Turing machine, which is infinite at both the ends, and somewhere in the middle of input tape, your input is written, and when Turing machine starts processing, then its read write head always points to the first character or first symbol of your input string. Now, as for one's complement and two's complement, we will have use binary numbers, and in binary numbers you can use only 0 and 1. Two digits are there. So suppose this is your one number 10101, which is stored on the tape, and before this and after this there may be any number of blank symbols there. So first, I will tell you the logic, and then I will create the transition or diagram of this Turing machine. So you can see here the logic for one's complement. As you know, friends, for one's complement of any binary number, you have to convert all zeros into ones and all ones into zeros. That means you have to invert all the bits. So for this particular number, the one's complement would be 0, 1, 0, 1, 0. So this would be the one's complement of this binary number. So your input would be this. This is your input, and this is your output. So when you are completing your process, that this must be on the tape. So now I will tell you how this particular Turing machine will work, and we will create the transition diagram of Turing machine now. Now in some cases, friends, when Turing machine works as a transducer, so there will be no final state, as it is not accepting or rejecting any kind of input, so there will not be any final state. If there is no final state, then when Turing machine will halt. So for such cases, you can create one special state. You can mention one special state there, which is to halt the Turing machine. So for example, we always take q0 as starting state. So in this particular machine, when for one's complement, if you are getting a 0, so you need to convert it into 1, and if you are getting 1, so you need to convert it into 0. So suppose you are on q0 and you are getting 1, so you can stay on q1, q0, you can stay on q0, and you can convert this 0 into 1, and you can move towards right. And then if you are getting 1 on q0, so you can convert this 1 into 0, and you can again move towards right. So these two transitions will convert all ones into zeros and all zeros into ones. So basically these two transitions will calculate the binary ones complement of given binary number. Now, when to stop this process, or when to stop this Turing machine? So we can have one special state, which is Q halt, you can consider as QH, and you can uh, consider it as Q halt. And when on Q0, if you are getting blank, so that means you have completed all zeros and ones. So when you are getting blank, so you will leave it as it is, and either you can move to left or you can move to right. So whatever you want, you can mention here. But this on getting blank on Q0, you will get move to one state which is known as Q halt, and it means this state, when your machine reaches this state, then it will automatically halt. So this is the Turing machine for calculating one's complement of a given binary number. So I hope, friend, it would be very much clear to all of you. Now we will take another example, which is 2's complement. So now 2's complement for any given binary number, suppose this number is given to you 10101. Now, how to calculate complement of 2's complement of this binary number? So you need to first calculate its 1's complement, 101010, and you will add a 1 in this 1's complement, so then you will get 2's complement of this number. So this would be 1 and 1, then 0, then 1, then 0. So this would be the 2's complement of this number. Now, is there any direct way to calculate this number? Yes, obviously it is there. So when you are having any binary number, you can directly calculate the complement 2's complement of binary number. So how it is done? Let me take some examples. So suppose for this particular number, if you want to calculate its 2's complement directly without calculating 1's complement, so what you can do, starting from right hand side, if zeros are there, then leave them as it is, and first one also you can leave as it is, and then after first one, whatever bits you are getting, you can invert them all. So for this particular number, if I want to calculate direct binary 2's complement of this binary number, so I will start from right hand side. So as no zeros are there, we are directly getting 1. So first one we will leave as it is, and remaining all bits after first one from right hand side, we will invert all these bits. So we will invert this, then this, then this, and then this. So this is 2's complement of this number, and you can see by traditional method also we have got the same number. So this is direct method of finding out the 2's complement of given binary number. So for one more example I will take here. Suppose you have number 1010. Now, what would be the 2's complement of this number? So we will start from right hand side, and all zeros we will leave them as it is, and first one also we will leave as it is, and remaining all bits after first one from right hand side we will invert. So this would be like this. So this is 2's complement of this number. So I hope this method is very clear to all of you. Now I will create transition diagram for this Turing machine. So friends, now we will start creating transition diagram for Turing machine that calculates the 2's complement of given binary number. So suppose this is your given binary number, which is 10101. So your head will point to the first symbol of this input string. Then you are on Q0 at the beginning of your process. So this would be your starting state or initial state. How we would be doing it? So we will first skip all these bits, whether it is 1 or 0, we will leave them as it is, and we will move towards right. And until we are getting blank there, then till we will move towards right. And we will leave all these bits as it is. So if I am getting 0, so I will leave this as it is and I will move towards right. If I'm getting 1, so I will leave it as it is and I will move towards right. Then we will get first blank here. So on first blank, we will move to Q1 state and we will leave this blank as it is. And we will start moving towards left direction now. So we are on Q1 here, we are on Q1 here, and we will get first digit here. We will get first digit here. So here you may get 0. So if you are getting 0, so you can stay on Q1. You can leave this 0 as it is and you will continue moving towards left. And when you are getting 1 on Q1, so again you will change your state to Q2 and you will leave this 1 as it is and you will continue moving towards left, but you will change your state this time. Now on q2 on q2, if you are getting 0, so you will convert it into 1 and you will continue moving towards left. And on q2, if you are getting blank, 1, so you will convert it into 0 and you will continue moving towards left. And on q2, if you are getting blank, on q2 if you are getting blank, that means you have completed all input symbols. So you will move to next state, which is q halt, and you will leave this blank as it is. And as you are reaching Q halt, so your machine will halt. So here you can mention either left or right, it doesn't matter. So this is the transition diagram for the Turing machine. So I hope this would be very much clear to all of you now. And still, if you have any doubt, you can always write to me in comments and I will definitely reply your comments. Thank you. Thank you so much.